Hello. Welcome to Introduction to Portfolio Theory. So here's the agenda for what I'm going to be talking about in this video. First, diversification of assets. Second, a two-asset portfolio. And third, efficient frontier and a minimum variance portfolio. So for those who don't know what an efficient frontier is, it's a set of optimal portfolios that offer the highest expected return for a given level of risk or the lowest risk for a given return. We'll be talking about this pretty shortly, so hold on to your seats. So there's a man by the name of Ray Dalio, who's a hedge fund manager. He manages a fund called Bridgewater Associates, and he's got a good quote here. It basically says the most important thing you can have is a good strategic asset allocation mix. So what the investor needs to do is have a balanced, structured portfolio, a portfolio that does well in different environments. We don't know we don't know that we're going to win. We have to have diversified bets. So a statistical way of saying this, which is diversification, is having zero or little correlation. Okay, so you want decorrelated assets to provide like a minimum variance, minimum risk portfolio. So we're going to start with an example now. So let's look at a two-asset portfolio. Here we've got the variance of the portfolio. We've got W1 squared, sigma 1 squared, plus W2 squared, sigma 2 squared, plus the weights, weight 1, weight 2, and the row 1, 2 is the correlation, right, between 1 and 2, which are the assets, okay? And then sigma 1 and sigma 2. So W1 and W2 are the portfolio weights. Sigma 1, sigma 2 are asset standard deviations. And finally, like I mentioned earlier, row 1, 2 are the correlation between the assets. Okay, so this is the standard formula for a two-asset portfolio. Now, we're going to, in the next slide, show you two different types of assets, okay? So one, we've got gold, right? Over long periods, approximately 20 to 30 years, the correlation between gold and the S&P 500 is usually slightly negative or near zero, often ranging from negative 0.2 to 0.2. And then we've got technology, right? Which has basically blossomed over the decade, 2 decades or so. And most large cap tech stocks move closely with the S&P 500, so their correlation is often closer to 0.7 to 0.9. So you can see the difference. Now we're gonna start off with two different assets. Okay, so it's gonna be Microsoft and gold ETF. And I'm gonna show you some assumptions. So here we have expected returns and standard deviations from Microsoft and gold. These are hypothetical, okay? The expected return and the standard deviation could be calculated from historical data. Okay, so that's usually how you would get those two, okay? So I'm going to restate the formula that we saw earlier, but in terms of the assets. So you see the sigma squared portfolio is equal to the weight squared gold, sigma squared gold, same with Microsoft, and then that 2 times W weight gold, weight Microsoft and the row one to Sigma Gold and Sigma Microsoft. Okay, so I restated it for this exercise. And we're gonna assume that rho is equal to 0. And because rho is equal to 0, that term disappears, right? Because we had the row in the that term. So now we just have this term, right? And the 0.12 and the 0.25 we saw earlier from the sigmas that we had. And then we have to constrain the weights basically to equal to 1, okay? If you look at this, okay, we could say the weight of Microsoft is equal to 1 minus gold, okay? Or we could say the weight of gold is equal to 1 minus Microsoft, right? So step one, what we want to do is find the minimum variance of the portfolio. That was kind of the objective that I mentioned early on, that we want a portfolio that is not volatile, right, for a given expected return, okay? So we're going to start off with that formula that we saw earlier, and then we're going to solve the weight for Microsoft that minimizes the variance of sigma squared. Now, in order to do that, we take the derivative of the portfolio with respect to the weight of Microsoft, right? And then if we do these like simple algebra, we put the square term in front, which becomes 2w, and then 1 minus Microsoft, the weight of Microsoft, that was gold, which I mentioned earlier, times the sigmas that we had, right? And we set that equal to 0. Now we're going to just rearrange some terms. And we finally get the weight of Microsoft is equal to 10.4%. Then 10.4% is allocated to Microsoft, and 89.6 should be allocated to gold, okay? So if that was like basically, so that's the allocation mix for our portfolio, okay? 89.6% of our capital should be allocated to gold. 10.4% should be allocated to Microsoft. Now we have basically step 2, which is setting an objective for the target return, right? So in this case, let's set it to 10%, okay? So we have the weight of Microsoft as times 0.15 plus weight of gold times 0.05. Those were the expected returns that we saw earlier, right? Is equal to 0.1. Solving for Microsoft and gold weights after some algebra, we get 50% Microsoft and 50% gold. We can then put that into the portfolio, and we get 0.03845 as the portfolio variance, and then we take the sigma, the square root of that, and we get 19.6%. Now we could do this multiple times over. And when we do so, when we make a bunch of expected return calculations, we get a different set of weights, different set of standard deviations, and the highlighted here is basically the minimum variance or minimum standard deviation portfolio, right? The minimum risk that we're willing to take, okay? We do get 7.22%, which is not the top return, but if our goal is just to find the minimum risk portfolio, this is what we would select, okay? Obviously, there are different criteria, different objectives. People have different goals. So based on that, we could kind of, if that's the case, we could make a educated decision as to what we would want, right? We could select 10.56% with 14.88%, right? If we're a little bit more risk tolerant, right? This could be also a generational thing, right? Millennials are going to be more risk tolerant than Gen X or boomers, right? So the minimum variance is probably something like a boomer would want to select. Here's the efficient frontier. This is basically just a graph of the table that we saw earlier. And it's the efficient frontier is just a set of best possible portfolios you can make given a group of assets. Okay, so that's Microsoft and gold. Anything below the frontier is inefficient, and then anything on the frontier is optimal, right? So that blue line is basically the best trade-off between risk and return. So let's review. Diversification first is what we went over. Having uncorrelated assets reduce risk. Minimize variance and a set of target return. This will allow you to calculate weights for your portfolio. And then finally, efficient frontier. After repeating calculations by setting different target returns, you can calculate the efficient frontier, which will show you the minimum variance portfolio. Thank you very much, and I hope to see you soon.